So, picture this. It's 2017. A team at Google drops a paper with this incredibly bold, almost poetic title that would literally change AI forever. Attention is all you need. Today, we're going to dig into why that simple phrase was such an absolute revolution. To really get why this paper was such a big deal, you have to start with a really fundamental question. How do you actually get a machine to understand the meaning behind a sentence, not just see a bunch of letters on a screen? For years, the best answer we had was, well, to do it sequentially. The model reads the first word, then the second, then the third. And it tries to piece together the meaning step by step. It sounds intuitive, right? But it created this massive, massive problem. Okay, so let's get right into this problem, what the entire field called the sequential bottleneck. You have to remember, before 2017, the AI world was completely dominated by models that worked this way. These models were called recurrent neural networks, or RNNs for short. And you could think of an RNN like it's trying to read a really long, complex sentence, but it's doing it by looking through a tiny little keyhole, one word at a time. It sees a word, tries its best to remember it, then moves to the next, just hoping it can hold the whole context in its memory. And the authors of our paper, man, they just hit the nail on the head with this quote. Because you have to go in order. Word 1, then word 2, then word 3. You just can't process the whole sentence at once. You can't parallelize the job. And that makes training these models incredibly painfully slow. This whole sequential thing created some major headaches. I mean, think about a sentence like, the cat, which was sitting on the porch all the way across the street, was orange. An RNN really struggles to connect cat with orange because they're so far apart. The information path just gets longer and weaker with every single word. This wasn't just some small bug, it was a fundamental bottleneck that was holding the entire field of AI back. This table from the paper just puts the breakthrough in stark black and white. Look at that top row for recurrent models. The work required, which we call O of n, grows with the length of the sentence. Longer sentence, more work. Simple as that. But now look at self-attention, the new idea. The work is O of 1. It's constant. It takes the same amount of time to connect two words, whether they're right next to each other or a whole paragraph apart. That's not an improvement. That's a whole new ballgame. So, faced with this massive bottleneck, the authors didn't just propose some little tweak. No, they proposed a complete revolution. Just throw out the whole sequential approach. Get rid of the RNNs, the convolutions, all of it. And they summarized their entire radical philosophy in the title of the paper itself. Attention wasn't just a nice-to-have feature anymore. They were arguing that this one single concept was all you needed. And this brand new architecture, built from the ground up on this principle of attention, got a new name. It was the very first of its kind, the transformer. So, how does this magic trick actually work? Well, instead of looking through that tiny keyhole, the transformer was designed to see the entire sentence, the whole page, all at the same time. The engine that makes all this possible is called self-attention. And just like the paper says, it's a mechanism that basically lets every word in a sentence look at every other word in that exact same sentence. It does this to figure out its own context and its own meaning. Let me break it down. Think of it like a little conversation happening inside the sentence. For the sentence, the boat sailed and it was fast, the word it needs to know what it's referring to. So it sends out a query, basically asking, hey, who in the sentence is most relevant to me? Every other word holds up a key. The word boat holds up a key that says, I'm a noun. The word fast holds up a key that says, I'm an adjective. The query from it gets a really strong match with the key from boat. So it then pulls the value, the actual meaning, from boat to understand itself. It's a beautiful system. Now, this is absolutely brilliant. But having just one of these conversations at a time, it can be a bit limiting. You know, a word might need to understand grammar and its topic at the same time. Trying to do everything with just one attention check can miss some important details, which, of course, is why the authors came up with an even better idea. So they introduced multi-head attention, and the paper specifically used 8 of these heads. You can think of it like having a panel of 8 different experts,
all looking at the same sentence at the same time. One expert might only be looking for subject-verb agreement. Another is just tracking pronouns. A third expert is focused on, say, the semantic vibe of the sentence. This lets the model look at all these different layers of meaning all at once in parallel.
Look, an elegant idea is one thing, but in science, the proof is always in the results. And the results for the transformer, wow. They didn't just nudge the needle, they completely broke the machine. So check this out. On a really important machine translation test, the previous best systems, and we're talking about ensembles, which are like teams of models all bundled together, they hit this score over here on the left. The single big transformer model, yeah, that's it on the right. By itself, it blew past the combined effort of all the older models.
And here's the real kicker. It got this new state-of-the-art result after training for just 3.5 days on only 8 GPUs. This was, and I'm quoting the authors directly here, a small fraction of the training costs of the best models from the literature.
And it wasn't a one-off. It was the same story for English to French translation. It set a new record there too. But just look at the training cost. That's basically how much number crunching it takes. The transformer wasn't just more accurate. It was almost 10 times cheaper to train. I mean, come on. It was better, faster, and cheaper. That's the holy trinity.
The authors absolutely knew they had found something profound. You can feel the excitement in their conclusion when they wrote this pretty understated but incredibly powerful line, signaling that this was not the end of the story, but just the beginning. And then they wrote this sentence, which might be one of the most prescient, most forward-looking sentences in all of modern computer science. They straight up said they were planning to use this for images, audio, and video. They were basically handing us the roadmap for the next decade of AI. You see, the transformer wasn't just another small improvement. It was a complete paradigm shift. It gave us a totally new foundation, one that was highly parallel, super effective, and is the reason we have things like ChatGPT and all the modern image generators today. And that leaves us with one final big thought. The paper made a wild claim about language, and it turned out to be spot on. So the question they were really asking, and the one we're still trying to answer today, is if attention is all you need for language, what else is it all you need for?